Hi, welcome to this new video tutorial. We're going to see right now how to run YOLO in a live video or from a webcam using OpenCV with Python. There are many options to use YOLO, especially when we work with YOLO in real time. One is with the CPU and the other one with the GPU. Let me explain quickly the few differences between them and what are the advantages and disadvantages of each one. With the CPU, there is only one really big advantage, especially for a beginner, is that we need only OpenCV and then YOLO will be ready to go without doing any other installations. But the big disadvantage is that it will be extremely slow. So I will suggest you to follow this tutorial only if you are a beginner and you never worked with YOLO before. The second option is to run YOLO on the GPU, so the graphic video processor, and there is the main advantage that it will be really fast in comparison with the CPU. You can reach really high speed and a real-time detection. And then there will be the disadvantages that it will be really hard to install. You need to compile many of the libraries yourself, and also it depends on the operating system. You will have some different challenges. So there are many things to keep in mind when you work with the GPU, and most likely we will see that in another video. For the moment, let's keep the CPU and let's start. We're going to perform our detection using this script, and this is where I explain how to detect object using YOLO but in a single image. So if you haven't watched my other video about YOLO, I will highly suggest to go and watch it, as we are going to use the same code, so you will have a clue of what we are going to do. And this was the code, and let's run it to see what was the detection that we did last time. And last time I was detecting the objects in this room, and we correctly detected the chair, the laptop, the TV monitor, and some of the books. Let's now understand the difference between working with an image and working with a video. Well, in OpenCV is almost exactly the same, with the only difference that when we work with a video, we simply work with more images one after another. So what we do right now is we go where we load the images, and I cancel this part right here. Instead, we load the capture from the camera. So cap is equal to cv2.video capture, 0 for the first webcam and 1 for the second webcam, and so on if you have more webcams. Now I'm using my first webcam, so I use 0. And then once we have the capture, we need to get the frames in real time. So we need to put them in a while loop, while true, and then we can say underscore frame is equals to cap.read. So what we are doing right now is we load the capture from the camera, and then on the while loop we take first frame, we execute the code below, and then again the loop starts again, second frame, and we do the processing on each frame each time. So as we need to work in the while loop, we need to put all the code below in the while loop until the cv2.wait key. Just press tab to indent all this code right here. And now let's adjust the things regarding this code. Instead of working with EMG, we're working with the frame, and here frame. So wherever we see EMG, we put frame, and then here where we draw the rectangle, frame and frame, and instead of showing EMG, we show the frame. Then the CV2 wait key, instead of 0, we need to say 1. The difference is that 0 is keeping the frame on hold open without going further, while 1 is saying just wait 1 millisecond, and then after 1 millisecond the loop will start again from here, and we will process the next frame. So just let's add something here. We also want to detect the key if we press any key, so that we can break the loop in real time and we can close the video if we don't want to go further. So if the key is equals to 27 and 27 is the S key on the keyboard, we break the loop. And remember to release the camera cap.release, so that Python will release the camera. Otherwise it can happen that Python will keep the camera open even if you are not using it. And then CV2 destroy all windows. And that's pretty much what we have to do to run YOLO in real time. So what I'm going to do right now is just to run the script, and let's see. Okay, and this is the detection of YOLO right now in real time. Let's show some object that I have with me right now. I have the phone. Let's see if it gets detected. Cell phone. I have another phone, Nokia. Let's see if it can detect the two phones, and that's okay. Let's take some book. Okay, also the chair is detected. The book not that well, and now the mouse gets detected as cell phone, and here the book. Let's see with the glasses also. Okay, we can detect the book anyway. Motorbike, okay, another mistake. But the first thing that should be clear to you is that the speed of this detection is extremely slow. And that's one of the disadvantages working with the CPU. What we can do right now is try to optimize as much as possible the code to make it faster. So let's do that right now. First thing, I was printing the indexes. We don't need to print them, so I will just cancel this one. And now, what we should do about the detection is that we need to process images, and the smaller the images are to process, the less material there is to process for the CPU, so it will be faster. And so we work with that right now, and we have the blob. So let's change the size of the blob. Here is where we change, where we prepare the images to pass them on the network where they will be processed by YOLO. So the blob now has a size of 416 by 416, and on YOLO accepts different sizes. One is 416, that's the standard one. The other one is 320 by 320, which is the smaller one. And then also bigger sizes like 608 by 608 and 800 something, I don't remember, probably 812 by 812. What we should know is that the smaller they are, the faster they will work, but also with less accuracy. And also let's do something else. I want to detect, to compare the speed between them. So what we want to do right now is to detect how many frames we are able to process in a second. So what we do is we import time so that we can count the seconds, and time now is equals to time.time. And also we want to count the frames, so frame ID is equals to 0. Each time we get a new frame, we simply add frame ID plus or equals 1. and then we go below before showing everything on the screen, and we process the frames per second. So what we do is we calculate how much time has passed. So elapsed time is equals to the time run not the time right now, oh yeah, the time right now, time minus the starting time. So instead of saying time now, let's say starting time minus starting time. So each time we know, each time that we show the frame, we know how much time has passed and also how many frames we processed. So what we do now is we need to divide the frames by the time so that we can know the frames per second, FPS. So FPS, it will be equals to frame ID divided by the elapsed time. And now we show this on the screen. cv2.put text, we want to put the text on the frame, and we will call this FPS frames per second, and then plus the string, and we add FPS. Now we need to define the position. We'll put this just in the top left of the screen. So let's say 10 from the left and 30 from the top. Font, and then we need to define the size of the text, let's say 3, and also the color, let's make it black, 0, 0, and 0, and the thickness 1. Here let's define the font before starting the loop, so it will be faster. I mean, we don't need to define the font on each loop, it will be the same always, so we can just say here the font is this one, and we will always use that. Let's see if we can choose maybe a better font, cv2.font. Let's leave this one, hair shape plain. And now let's run the script and let's see what we get, and most of all if we got some improvement of the speed. Okay, this is the frames that we are processing per second. As you see, 0.6 around each second we process around each 2 seconds almost we process only 1 frame. It's still really slow, but much faster in comparison that it was before. Now we're around 0.7, and you might have a better result if you have a better CPU than I have. Let's say old computer with Intel Core i5. Let's now try with some object. Cell phone. Well, I have the same object of before. Let's see if I can find something else. I don't know if the headphones are part of the data set and can be detected. Probably not. Okay, it's still anyway a decent result in comparison with before. And what we can do now is try the same detection in a live in a video from a file. So instead, right now, instead of loading video capture, I load the file. Let me see which file I have. I forgot the name. On YOLO I have, okay, working MP4. And also, if you want to test the same file, I will put the file on the tutorial so that you can download it. Working.mp4. Let me increase the size of the script. Okay, working MP4, and let's run the script right now. And let's see what we can detect on this. Okay, this is the detection on a video from a file, and we are processing still around the same 0.7 frames per second, which is a terrible speed in a live video. And the problem is that on the video we process all the frames, so if a video has 30 frames per second, we need more than 30 seconds to see only 1 second of the real video, and this is a big problem. But I want to introduce right now to another version of YOLO, which is Tiny YOLO. And Tiny YOLO is YOLO optimized for CPU, so is optimized for the speed. So here instead we have the weights and YOLO version 3 weights, and then the configuration file of YOLO version 3. And now instead let's load YOLO version 3 Tiny and YOLO version 3 Tiny configuration file. And also you can download this file. I will put the link on my video tutorial, just that you can download this file. So you need them right here. So I have weights, I have YOLO version 3 weights and YOLO version 3 Tiny weights, and the same is for the configuration file, YOLO version 3 CFG and YOLO version 3 Tiny CFG. And Cogo names is the same, as they work with the same datasets of these 80 objects that are here. So let's now try Tiny YOLO and let's see what speed we get. We'll try Tiny YOLO on this same video, and let's run the script. Okay, first let me increase the size, and now run the script. Okay, now it's much faster. We get around 5 frames per second. We don't see that much the number here, but it's 5.5. Let me increase this. So let's say 4, and then thickness, let's say 3. And also I want let's show FPS only. Let's round the FPS, round FPS only to the second 2 digits after the dot. So let's run it right again. Okay, now it's better, but we don't see it. I will put I need to put this a bit below, so let's change the position. Let's say 50 instead of 30, and now let's run it. Okay, this is the number of the frames per second that we are processing, so around 5 frames per second. But what you can notice is that the detection is much less accurate than with the real YOLO. So even this track, it's not detected quite well. You can see that on some frame the person is not detected at all. I want to try again on this with the webcam, and later I will explain how we can do some other improvement. So instead of video capture working MP4, let's load a 0, which stands for the webcam, and let's run again the script. Okay, you can see now the detection is quite okay, and also it's not really smooth, but it's almost detection in real time. We have around 6 frames per second. And you need to keep in mind that I'm also recording the screen, so my CPU has been used by the recording software, so you might get much faster in this. You can get, I believe, also 10, or if you have maybe a new computer, also 15 frames per second only with the CPU, which is a great result. Let's check how the detection works. The phone is not detected. Of course, it's not as strong as the YOLO, because Tiny YOLO is the fast version, but not as accurate as YOLO. What we can do right now is to try to changing the threshold of the algorithm to see if we can get a better detection or even faster. It depends. Let's see. I mean, not faster. To get it faster, you need just strong computer. As here is the smallest we can use. I believe 320 is the smallest, and of course, if you will use even smaller than this one, then the detection will really suck. So let's keep this one, and let's just change the threshold. So we can try changing this one, and what happens is that if we increase this threshold, we will get less objects, but the detection will be more accurate. But if we decrease this number, we will get more objects, but the detection will be less accurate. So we will get also detection of what the algorithm is not really sure is correctly detected. And also what I would like to show to add is the confidence of the detection. So let's take also the confidence right here. Confidence is equals, and we need to get the confidences I, and I see that probably I did some mistake here with the colors, because we need to take the color from each class and not for each object. So this was a mistake I did in the previous code, so I'm just correcting it right now. And then let's display the confidence. cv2.confidence, no, what confidence? cv2.put text, and we need to put the text on the frame and then the confidence, or better after the label. That's it makes more sense to put it just after the label, so you will see the name of what's detected, and then with which confidence plus confidence. And let's of course this must be a string, and also we want to round the confidence number, so round, and we will have only two numbers after the dot. And let's run the script. Okay, now we see also the detection, and we see the confidence. So this is like almost sure that it's a person. So it's good threshold for the confidence. Here we don't see anything for the, okay, cell phones 0.7. And another problem of YOLO is that when two different objects are really close together, the detection can't work correctly. That's some of the disadvantages of the algorithm. Anyway, 6 frames per second. In the next video about YOLO, I'm not sure if it will be the next one, but the next about YOLO, we will see how to use YOLO with the GPU on the NVIDIA Jetson Nano. So stay updated if you want to see the video about Jetson Nano. And just a quick reminder that I'm working on a video course about Raspberry Pi with OpenCV, and also I will add some extra module about Jetson Nano, and then computer vision with deep neural network and artificial intelligence in general. So if you want to stay updated, I will put somewhere a link below in the description where you can sign up. You can put your email, and I will let you know as soon as I have any news about the video course release. This is all for the moment. Enjoy your video detection.